Hi, my name is Jun Chikushi. I'm one of the members of the engineering group. Our group's topic is comparing life cycle carbon dioxide emissions of gasoline-powered vehicles and electric vehicles in Japan. Now, there is a worldwide transition from gasoline-powered vehicles to electric vehicles, which is called EV shift, and and this is also occurring in Japan too. So there is a need to assess carbon dioxide emissions for both vehicle types in Japan and evaluate which is really more environmental friendly, considering that one of the causes of global warming is carbon dioxide. A previous study in the US showed that when there are more than 60,000 kilometers, electric vehicles is more environmentally friendly option. And when there are less than 60,000 kilometers, gasoline-powered vehicles is a more environmentally friendly option. Using the previous research, we made two hypotheses. First, as a premise, electric vehicles emit more carbon dioxide than gasoline-powered vehicles in the production part. In this part, we use the data of the previous research. And as a hypothesis one, carbon dioxide emissions per kilometer of gasoline-powered vehicles is more than those from electric vehicles. We thought so because gasoline-powered vehicles would emit exhaust gas which contain carbon dioxide when they run, but electric vehicles don't exhaust such gas. And as a hypothesis two, we thought the break-even distance where carbon dioxide emissions from gasoline-powered vehicles and electric vehicles are equal would be 90,000 kilometers. We calculated this value considering the data of the previous research and fuel efficiency and energy requirement in Japan and in the US. Next, I talk about the method and result part. First, we did regression analysis using 12 different gasoline-powered vehicles which are widely used in Japan. And as a result, fuel efficiency of gasoline-powered vehicles is 13.98 km per liter, and carbon dioxide emissions from exhaust gas when they run 1 kilometer is 0.181 kilograms. Next, we calculated carbon dioxide emissions for each phase. As you can see from this graph, carbon dioxide emissions from producing one electric vehicle is more than twice as much as those from producing one gasoline-powered vehicle. On the other hand, for the driving phase, carbon dioxide emissions from running 1 kilometer by gasoline-powered vehicles is more than 4 times as much as those from running 1 kilometer by electric vehicles. And in this part, we assume that crude oil would be transported from Middle Asia to Japan, and crude oil would be refined in Japan. Using these results, we did break-even point analysis. The left graph on the slide is our goal. This graph shows that total carbon dioxide emissions against the driving distance, and the break-even distance would be 22,000 kilometers. On the right graph, the intercept means the carbon dioxide emissions from producing one vehicle, and the slope means carbon dioxide emissions from running 1 kilometer. Finally, I'll talk about the discussion part. As a result, the break-even distance will be 22,000 kilometers, which means when there are more than 22,000 kilometers, electric vehicles is more environmentally friendly. However, there is a big gap between our result and our hypothesis. One of the reasons for the gap is the data's variation in terms of the region, like gasoline ratio. In this research, we assume that gasoline ratio from crude oil would be 90%. However, one of the database in the US shows that gasoline ratio in the US is 43%. Using this data, the break-even distance would become 1.5 times bigger. And research has some limitations too. One of them is that we didn't think of the disposal phase, which is necessary to do full life cycle assessment. This is the end of the presentation. Here is a reference. Thank you for listening.